share with you guys today. This PowerPoint is a little bit long, but I believe everything will be worthwhile. Hopefully, if I don't finish, you guys can have access to it and actually go over it. On your own time. That just in case I don't finish. But anyway, this will be chapter 6 for 1324. It's going to be systems of equations. So today, guys, I'm going to cover the one with the box here. This is section 6.1. This is section 6.2, and the last part here, applications of problems with three variables, is section 6.3. Okay, now, so let me just continue. Okay, first of all, guys, before we start, let me start out with what this topic is all about. When you have two lines or two equations, and you're looking for the point of intersection, you can actually check by plugging in the point to both equations. For example, on these are like the first two of the homework for 1324 for 6.1. It says determine whether the given order list of numbers is a solution of the systems of equations. So for equation 1 here, we have -1, 3, the point. And let's see if it's a solution for those two equations. And then number 2, the same thing. So let's start with problem number 1 there. We're going to plug in -1 for x on both equations and 3 for y. And if both answers, say for example, in equation 1, if this part gives me 1, then it's true. But it also has to be true for both of them. Okay, so let me show you what I'm talking about. So this is equation 1 and equation 2. When I teach this class, I like to say equation 1 and equation 2, or 1 or 2, because to me, it wastes too much time saying the equation 2x plus y equals 1. To me, that's too much, wordage. So I rather say equation 1 or 1 and 2, okay? So for example, here on equation 1, I'm going to plug in, it's saying that x is -1, so I'm going to plug it in there, and y is 3, I'm going to plug it in there. Then we're going to evaluate it to see if the left side equals to the right side. This will be -2 plus 3, so we get 1 equals to 1. So once it's true here on the first equation, then we can proceed. But say this was not true, say this was like 3 equals to 1, that's not true, so we stop. So that point would not be a solution. But here, since it's true, we continue to equation number 2. And again, we do the same thing. We plug in -1 for x and 3 for y. So we get 3 plus 6, so we get 9 equals 9. So that means that this point is a solution to these two equations, which means that's where they intersect. Okay? Okay, now, let me continue here. This is equation number 2, so we're going to do the same thing, but these are, this is another point for two different equations. So like the same as before, we're going to plug in 2 and -5, 2 for x and -0.5 for y. So again, equation 1, equation 2. So first we get equation 1, and we plug in the values 2 for x and -0.5 for y. Let's see what it gives us. It gives us 1 minus 4, so this is true, right? So we can proceed. Now let's go to equation number 2. We do the same thing. We're going to plug in 2 for x and -0.5 for y. But if we notice, guys, here, we're going to get 2 minus 2.5. We get -0.5 equals to -5. Is that true? No. So this point is not a solution. Since the order pair 2 -0.5 does not make both equations true, then this order pair is not a solution. So to answer the question, is 1 a solution? Yes, it's a solution. This point is a solution to these two equations. And for number 2, is not a solution. Okay, why is this crucial here, guys? Because when they give you two equations, you can actually plot the points. If it was multiple choice, you could do it that way. But in 1324, there's no multiple choice questions on the homework. So that's why you have to know how to find the answer. Okay, now this is the graphic method. I copied and pasted this from the first figure, which is 6.1, and this is crucial. Because here, guys, this is what we're looking for. The points is where they intersect. So if the point, for the two lines intersect, that's my solution. So for example, the two lines intersect at exactly 1 point. So 3, 2 is a solution for those two equations. And here, this is called infinite solutions. Why? Because there's two lines. One line lies on top of the other one. That means it's infinite solutions. And the one on the far right, this is no solutions because the lines are parallel. These two lines will never intersect. That's why there's no solution for this one. Okay, now in this section, they don't show you graphing because most of the authors that write books, once they explain a topic, they don't do it again. And that's a theme with some of the students, is that they forget some of the material that they should have known by now. Okay, but here it says graphing lines is 2.1. So again, in this section, they don't show you how to graph, but I'm going to graph just one for you guys. Okay, so you guys can have like a refresher. Okay, now when we actually try to solve the system by substitution, which is one of the topics, or by the elimination method, here are key points. Or like an observation, when is going to be one solution. For example, if you get an answer for x equals to a number, you see let a and b be real numbers. If you get an answer for a or for y, that means it's going to be one solution. Okay, example, x equals 3, right? Or y equals 2, we're going to get one solution. Now, for the one that has infinite solutions, here it says let a equal a. This guys, I have to explain the concept because a lot of students get stuck here because they don't understand how to write the math. Here it says let a be a real number. This can be any numbers. For example, 3 equals 3 or 0 equals 0, right? That's what a equals a means. So when you have something like this at the end, and if you notice there's no x or y, that means it's going to be infinite solutions for this one here. And for the no solutions, it's the same thing, a equals b. Let a and b be real numbers, which means these can be any numbers. But if you notice, the numbers are not going to be the same. Example, 3 equals 4, right? That's not true, because 3 does not equal 4. That means that at the end, when there's no x or y, this is going to be no solution. Okay, now this system here on the left, when you have one solution, is called consistent independent system. Every time you can have a solution, for example, for these two forms, where you have one solution or infinite solutions, it's called consistent. But when you have one solution, it's called independent. When you have infinite solutions, it's called consistent but dependent. Because it's a dependent system. And when there's no solution, it's called inconsistent. Okay, and these at times. For example, like in 1314, some of the instructors or the authors, they make you know this right here. But in 1324, they don't put too much emphasis on this. But I want to put it just in case you want to change majors to math or something. Because most people that are going for math engineering, they have to know this stuff here. Okay? Okay, now, so again, this section doesn't do the graphing part, but I'm going to show you how to graph. Okay, this is number 3, okay? File number 3, I did the first two on the second power slide. Okay, here, I'm going to solve this one, this very same set of equations by graphing, by the substitution method, and by the elimination method. There's actually 4 ways to solve a system. One is by graphing, by substitution, by the elimination method, and by using matrix, okay? Okay, now by graphing. So by graphing, I'm going to put equation, start with equation 1. Right, so this form is already in the y equals to mx plus b. If you remember from section 2.1, I need to find my slope. My slope will be 3, right? But you always put it as a fraction because this means this will be the price, the 3, and the run will be the 1. And my y-intercept is always a b. So b equals to -6, y equals to 0, -6. So this is my starting point. Okay, so the graph is there. So first, let's graph 0, 0, -6 because the b, which is the y-intercept, is the starting point. So I'm going to put the point right there. There's where you start. Then since these are both positive, I'm going to go up 3, 1, 2, 3, and 1 across. You plug it in and then just draw your line. Because it only takes 2 points to draw a line. But if you notice, if you continue 1, 2, 3, 1, 1, 2, 3, 1, you see it's always the same point. because they got the same slope. Now, let's do equation 2. Equation 2, I want to follow the same format as put it in the slope intercept form. But I have an easier way, to do it this way, but I'm not going to show you here, okay? Which is using the x and y intercept, but that's another story. But for now, let's put it in y equals to mx plus b form, which is the slope intercept form. Okay, so I have to solve for y, right? I want the y by itself isolated. So first, I'm going to add 5x to both sides. If I add 5x, right, it's going to cancel here, and then the 5x will go to the right side. Now, I'm going to divide both sides by -2. And if you do that, you're going to get -5/2x plus 5. So what's my slope? My slope is -5/2. And what's my b, or the y-intercept? 0, 5. So this is my starting point. So I'm going to start right about there. There's my starting point. Which means, right, since it's negative, if I want, I can put the numerator as negative and the denominator as positive, or vice versa. Okay, check this out. If I want to put this one negative, I'm going to go down. 1, 2, 3, 4, 5, and then 2 across. 1, 2. But if you want to make this one positive and this one negative, then you will go out. You see, but there's no space over here. 1, 2, 3, 4, 5, and then 1, 2. Eventually, it will be the same point. Okay, but let's do it this way. Let's put the 5 as negative and the 2 as positive. So this way, we're going to go down 5 and 2 across. So the point should be right about there. And then we draw our line. So the answer is, the point where both lines intersect is the solution. So this is the answer, which is 2, 0. Okay, now, when you do it by graphing, you have to use graphing paper. Because if you go sloppy with the way you set up your graphs, and if you don't put them the same set of units, your answer might be deceiving. That's why when you do math, you take your time and you do everything real nice and neat. And instructors like that because we don't like to grade like sloppy papers. As a matter of fact, I get upset when I see a sloppy paper, and I never forget that name because every time that they're going to grade the exam, I say to myself, "Ooh, here comes this guy again, or this girl again with a messy paper." And to me, it's kind of aggravating. So please, guys, always do your work real nice and neat. You'll be surprised how pleasant that is to the instructors. Okay? Okay, now, if this section doesn't cover graphing, why am I doing graphing for? Because guess what, guys? If you're taking 1325, you have to know how to graph for chapter 7. Graphing is crucial, but you're going to be graphing inequalities. So that's why I kind of threw a graph in here. Okay? So this system is consistent, right, and dependent. Why? Because you have a solution, and it's not infinite. You have one solution. Okay, now, so that's it for the graphing part. Okay, now I'm going to do it by substitution. If you notice, you see, it's the same equation. I'm going to do it like 3 or 4 different times. The same one, just so you know that you can do it 3 or 4 different ways, okay? So by substitution, again, equation 1 and equation 2. Solution, since y is isolated in equation 1, we substitute 3x minus 6 for y in equation 2. Because at times, students always ask me, Mr. Isasi, well, what should we do here? I always tell them, try to isolate one of the variables, either the x's or the y's. In this case, equation 1, the y is already isolated, so it's easier to use equation 1. And you're going to plug it in. You're going to plug in 3x minus 6 in equation 2 right here. Okay? So there's equation 2. And I'm going to plug in, or substitute 3x minus 6 for y, which is, I'm going to plug it in right here, right? This is my y here. So I'm going to plug it in. And then I'm going to distribute. So we get negative 5x, right? Because we multiplied negative 2 times 3 will give us negative 6. Negative 2 times negative 6 will give us positive 12. Now we're going to combine like terms. These two are considered like terms. So negative 11x plus 12 equals negative 10. Now this is just simple algebra. I'm going to subtract 12 to both sides. And we get negative 11x equals to negative 22, because if we subtract negative 12 minus 10, it's going to give us negative 22. Now we get to divide by negative 11. So we know that x equals 2. At times, guys, a lot of students stop here. because they don't know really what's going on. That's why it's always the answer will always be like an ordered pair. That's why I started the first slide with an ordered pair, because we found the x, now we have to find the y. So we need to find the y. Plug in 2 for x in either equation 1 or 2, whatever is easier. In my opinion, it's easier to use equation 1. Why 1? Because the y is already isolated. So all we do is plug in the 2 for the x, right where the x goes, which is right there. And then it would be 3 times 2 is 6. 6 minus 6 is equal to 0. So x equals 2, y equals 0. So what's my solution? Is 2, 0. And again, this is consistent. And why am I doing this? So maybe this can stick to your heads. That this is called a consistent independent system. Okay, now I'm going to do a different approach by the elimination method. I got this one. I'm going to do it twice, because a lot of times a student asks me, "Hey, Mr. Isasi, well, why should I eliminate the x's or the y's?" So here, guys, I'm going to do it both. I'm going to first eliminate the x's and see what happens, and then eliminate the y's. Okay, but before we start, we have to set up both equations in the ax plus by equals c form. Here in this book, they just say the rho ax plus by equals c. They don't give it a specific name. They just say the rho. Okay. So need to rewrite equation 1 in proper form. For example, equation 1, right, is not in ax plus by equals c form. So then I need to subtract 3x from both sides, right? So minus 3x here and minus 3x there, right? This will cancel here on this side, so it'll give me negative 6. So we have negative 3x plus y equals negative 6. Now it's in the ax plus by equals c form. Okay, so again, this will be equation 1 and equation 2. Here, you're going to say, what should we get rid of here? The x's or the y's? It doesn't matter, guys. But here it's easier to get rid of the y's because I only have to do one multiplication. If I multiply this by 2, won't it give me 2y? And then when I add them, they'll cancel. So again, to eliminate the x's or y's, whatever is easier for you, I'm going to eliminate the y's here first because it's easier. So I multiply this whole equation by 2, which is legal, as long as you multiply 2 to both sides of the equations. Of the equal sign. So 2 times negative 3x is negative 6x. 2 times y is 2y. 2 times negative 6 is negative 12, right? And then this equation, we'll just slide it down. Slide it to the side. And then we're going to add them. That's why it's called the elimination method or the addition method. They both mean the same thing. So negative 6x minus 5x is equal to negative 11x. These two will be 0. So we have negative 11x equals to negative 22. We divide both sides by negative 11, so x equals 2. And again, I need to find the y, so we can plug it in either 1 or 2. Again, what's easier? In my opinion, the number 1's easier because the y is already by itself. You see, we get the same thing as before, so we get 0. That's my solution, and the system is consistent and dependent. Now, on the next slide, it's going to be the same thing up to here. Okay, up to here. But I want to get rid of the x's instead, just so you see how much more work you need to do. So when you see a system like this one here, system of equations, you try to think what will be easier for you. I'm saying right here, what will be easier for you? Okay, why should you eliminate the x's or the y's? For example, here I did the y's. Now on the next slide, I'm going to do the x's. Okay, so we start the same way. That's why I'm going to go a little bit and get to that point right there, which was right here, right? So now, guys, look how much work it's going to be. If I want to cancel the x's, then this one I need to multiply by negative 5 and this one by 3, or vice versa. It will give us negative 50, and it will give us 15x minus 5y equals to positive 30. And here I'm going to multiply by 3. You need to multiply one by a negative, right? Because they're both negative. Because if we multiply both by positive, isn't going to give me a 0. They're not going to be eliminated. That's why you have to multiply one by negative. It doesn't matter which one. So here we get negative 15x minus 6y equals to negative 30. So here we get negative 11y equals 0. So divide both sides by negative 11, and we get y equals 0. And again, here, we need to plug in y. To find the x, we need to plug in 0 for y, and see in this case, see which one's easier. In my opinion, it's easier to use number 2. Because for number 1, I need to put 0 there, and then I need to send the 6 over there, and to me, it's too much work. But even for me, if I say it's too much work for me, maybe for you guys, it won't be too much work. So it all depends how you want to approach it. Here, I'm going to use equation 2. So I'm going to plug in 0 right here for the y. So we got negative 5, x equals to negative 10. We divide both sides by negative 5, so we get x equals to 2. So that's my solution. And again, this is an independent system. Okay. Hey guys, up to this point, you guys have any questions? You guys okay up to this point?
There's no questions so far, Mr. Azasi.
Okay, perfect then. So let me continue then. Okay, now. Hey guys, remember the second slide that I had those graphs, and I showed you that if you have x equals to a number, it's going to be one solution, and you have something like the same numbers, like a equals to a. Remember that this is the case here. Okay, where you're going to have like 3 equals to 3 or 0 equals to 0, which means it's going to be either infinite solutions or no solutions. Okay, so check this out. Again, this is equation 1, equation 2. So here, guys, I'm going to get rid of the x's. So I'm going to multiply everything by negative 2, because negative 2 times 3 will give me negative 6, right? And then when I add them, they'll cancel. But look what happens. Negative 2 times 3 is negative 6. Negative 2 times negative 2 will give me positive 4y. Negative 2 times 4 is negative 8. And if you notice, it's the same equation. I mean, they're opposites, so they're going to cancel. They're going to be eliminated. You see, we got 0 equals 0. What does this mean? It's going to be a line on top of the other line, which be infinite solutions. So this is a consistent dependent system. Okay, now, hey guys, check this out. Observation here. When you see a system of unit equations, 2 of them, right? If you multiply one by something, right? For example, this is double, and this is double. So right away, you should know it's no solution. It's infinite solutions, because it's going to be 0 equals to 0. Okay, so like I'm saying, from equation 1 to equation 2, right? Everything doubles, and you have the same sign, which means as an observation, it's going to be infinite solutions. Okay, this is number 7 here. Check this one out. What would the answer here be? Right, by observation, right? This one triples, but this one does not triple. So here, this will be observation, that this will be no solution. Okay, but let me show you the work. Because if that was a 24, then that will be also infinite solutions. But in this case, that won't be the case. This will be no solution. But let me do the work to show you. I just want to show you like an observation there. Okay, again, I'm going to get rid of the x's. I'm going to multiply everything by negative 3. So it will give us negative 3x minus 15y equals to negative 24. So if we add them right down, we get 0 equals to a number, right? Remember for this one, it was no solution. We get 0 equals to a number, and that's not true. Therefore, for this one, guys, it's going to be no solution. And that's inconsistent system. Okay, now let's see how this relates to the real world. Okay, like a real life problem. And I got this one from the homework, right from the book. Okay. It says here, a 200-seat theater charges $8 for adults and $5 for children. If all seats were filled and the total ticket income was $1,435, how many adults and how many children were in the audience? Okay, so what approach should we take here? This is the approach that I always tell my students. You need to find 2 solutions. Okay? I tell them that we're going to do tickets, or seats with seats and money with money. What does that mean? That I'm going to do the seats, for example, here I'm going to let x equals to adults, right? Adult seats, and y equals to children's seats. You see, seats with seats. So there are a total of 200 seats. So this will be x plus y equals to 100, which means adult seats plus children's seats equals to 200 seats. Okay, that's why I say here, that's what it means, seats with seats. Okay, now here I'm gonna do money with money. So here the adult tickets are $8, right? So for adult tickets, I mean for the adult seats, isn't it X? So that will be 8X. For the children tickets is $5 and Y represents children's seats, so that's gonna be 5Y. And what was the total revenue? So total income or total revenue is gonna be 1435. So it's gonna be 8X plus 5Y equals to 1435. You see, guys, I found my two linear equations. Now, you can actually solve it by substitution, by graphing, or by elimination. Graphing will be out of the question because that'll be too hard, because the numbers are too big. In my opinion, guys, this will be easier to do it by the elimination method. Because for substitution, you have to solve for one of these variables and then plug it into the other one. To me, that's too much work. Okay, but a lot of students prefer to do it that way. You do it how you feel comfortable. Okay, but I'm going to show you how I would do it and how I explain it in my class. So again, this is equation 1 and equation 2. So I'm going to get rid of the x's, I believe, in equation 1. Here you can get rid of the x's or the y's, it doesn't matter. Here I show the x's. So this has to be negative a, right? So they can be eliminated. But I have to multiply negative a times every term. That's what I get. Okay? And then, right, and then we add them. So these will be eliminated. So we get negative 3y equals to negative 165. We divide both sides by negative 3, and that's my answer. So if I divide negative 165 by negative 3, it will give me 55. Now, I need to find the x value. So I'm going to plug in 55 for y in either 1 or 2. What's easier? In my opinion, 1's easier because it'll be less work. Y equals 55, right? So I'm going to plug in 54 for y. There it is. So subtract 55 to both sides. So x equals to 145. What does that mean? That x equals to 145 and y equals to 55. But what does x represent? Adult seats. And what does y represent? Children's seats. So that's my solution. Okay? And this is how you can apply it like to a real life situation. Okay? Okay, now this starts 6.2. This is larger systems of linear equations. Okay, you see, now we're going to have 3. This is like in 3D. We have x, y, and z. Okay, equation 1, equation 2, equation 3. So here, guys, the strategy is because we have to have some kind of plan. So like I tell my students, the plan is you always try to have the one that has a 1 as a coefficient on top. But if there's none, well, there's nothing you can do. You have to work it that way. But here, guys, it's always good to rearrange it. Rearrange if possible, coefficient of 1 on the x being equation 1. For example, this one, I'm going to send it to the top or switch them. You see, so all I did was switch 1 and 2. Okay? Okay, now, so here, this is my plan. So what's the plan? Because a lot of students, they always say, what are the steps? It's no good to know the steps, guys, because at times, when an instructor gives you the steps, well, it depends what it is. But a lot of students, they want to copy the steps. What are the steps? No, you have to know the material. So that's why, guys, I come up with a plan. Not the steps, a plan. So this is a plan. Okay? If you follow this method, guys, you can never go wrong. Trust me, you can never go wrong. That's what I taught to my students. And it actually works. So the plan is I'm going to get equation 1 and 2 and equation 1 and 3. And I'm going to get rid of the x's, eliminate the x's. Okay? Usually I say I get a new equation, equation 4, but here, guys, I'm going to say new equation 2 because this way, this relates to how you solve it with matrix. Because with matrix, they call this the new row 2. So I try to do it more or less so you guys can make a connection. So this will be my new equation 2. This equation will not have an x. It will have something y something plus z something equals to something, but no x. And we do the same thing with equation 1 and 3, right? We eliminate the x, we get a new equation 3. Then we get equation 2, the new equation 2, and the new equation 3, and guess what we do? We get rid of the y's, eliminate the y's. After we do that, we get z by itself. Z equals to c. What does that mean? At times, guys, I like to put here like a number sign because a lot of times students get confused with another letter. So that's why you have to say what C is. Let C be a real number. C can be any number, okay? But at times, I like to put here a number sign because I don't like for none of my students to be left out. And at times, some of the students don't know the vocabulary. That's why, I always do it both ways. With the vocabulary, the way it should be taught, and then I can lower it down to the level of the student, okay? But this, also at times, I'm known to put a number sign here, okay? After all the steps, right, after you do all that, your equation should look like this, okay? You see, there's my Z. And remember these two, I can put either one of these two here. You see they don't have an X because it was eliminated over here. So then it means you're going to back substitute to find the answer for X, Y, and Z. Okay, I'm going to do this very same one. I'm going to do it, this one here on the next power slide. There it is, the very same one. But now we're going to execute the plan now. Equation 1 and 2, there it is. So I'm going to get rid of the X's. So, hey guys, for the very same reason, it's always wise to put equation 1 with the X by itself. With no coefficient, because it's easier to do the math. You see, that's why this one, I'm going to multiply this by -2. Because -2 times X will give me -2X. And when I add it with this one, they'll be eliminated. That's the purpose. We have to multiply -2 times every term. You see, guys, the x's are eliminated, so I'm left with 4y minus 3z equals to 3. Then I repeat the process, right? This is my new equation now. Then I repeat the process with 1 and 3, right? That was the plan. Use 1 and 2 and 1 and 3, get rid of the x's. So I'm going to repeat the process, but this must be a -3, correct? So that way they can be eliminated, and there's my -3. So if you multiply -3 times every term, this is what we get. And then when we add them, right, the x's are eliminated. So this will be my new equation 3. Now, what was the next step? We get equation 2 and equation 3, the new ones, and we're going to get rid of the y's. So here, guys, most of the times, they tell you to multiply by the least common multiple. The least common multiple will be 20. But here, guys, so that way I won't give you no more things to think about. Just multiply this one by -10 and this one by 4. Just multiply by the opposite of these numbers. It will always work. So this one I need to multiply by -10 and this one by 4. And again, but if you can get the least common multiple, which will be 20, then you can multiply that one by -5 and that one by 2. But I just like to do it this way. This one you multiply by what's up here, and this one you multiply by what's down here. But since it's both positive, one has to be negative, and it doesn't matter which one. So if you multiply -10 times every term, this is what we get. -40y plus 30z equals to -30. And same thing on equation 3. You see, guys, we get 2z equals to -2. We divide both sides by 2. So we get z equals to -1. Now, remember where I said this is what we should get? So here, guys, this is my z, but for the second equation, you can either get new equation 2 or new equation 3. It doesn't matter which one. I like to get the one that's 2 there. But if you put this one, it doesn't matter. It's still the same thing. Now, we're going to back substitute, which means I'm going to use the third equation, right? Because it's already, I selected the z, which is -1. I'm going to go to equation 2, and I'm going to plug in -1 for z and solve for y. Then I subtract 3 from both sides. So for y equals 0, so then I divide by 4, so y equals to 0. Now I know what the y is and what the z is. Then I go to equation number 1, and I repeat the process, but with y equals 0 and z equals -1, right? I'm using these values here that we got right now. So again, I'm going to plug in 0 for y and -1 for z. So we come up with x minus 2 equals 0. We add 2 to both sides. So x equals to 2. So what's my solution? That's my solution. That's x, y, and z. So it's 2, 0, -1. Okay? And this was number 9. Okay, that's why that kept at the end. Because I forgot to put it there, and I don't want to start again without the animation. I would have been there for a long time. Now, this is I got about 20 minutes, guys. This is the most, I think this is the hardest one and also the most important one, because if you ever you switch from whatever career you're going to, because 1324, they don't really go for math. Most of the people going for 1324, they're actually not math majors nor engineers. But if you ever want to switch, you have to know how to use this method. This is using matrix, okay? And again, the objective, this is my linear systems of equations, right? So I have to put it to augment it. And then this is an RRF, stands for reduced row echelon form. So if you notice, this is the same equation that we did right now, right? I think the answer was 2, 0, -1. So that's what we should get. So how do we convert this linear system of equations into augmented? You see, you put a matrix. These are the coefficients for the x, y, and z, and also for the constant over here. So this one will be, hey guys, I will ask you to participate here, guys, but I want to make sure that I cover it. Okay, so I'm just going to keep going, okay? Here is going to be 2, -2, 1, and 3. There it is. This is going to be 3, 1, -1, and 7. There it is. This is called augmenting matrix. Now this should look, once you get the answer, it should look something like this. You see, there's a 2, 0, -1. This means the x goes here. This is the x, this is the y, this is the z. Which means 1x plus 0y plus 0z equals 2, or x equals 2. Y equals 0, and z equals -1. Okay? But how are we going to do it? How? Okay, now, this is the plan, guys, that I came up with. And also, I did the same PowerPoint, but for the development week for other instructors. And I plan on doing it again, because last time I didn't know about sharing my screen and all that stuff, so my presentation didn't come out too good. But now with sharing the screen, I'm excited that I'm going to put a proposal to repeat this workshop on how to do the Gauss elimination method and the importance of it too. Okay, so this is a plan, guys, that I came up with. I didn't invent nothing, guys. What I did is I just what's the right word to say? I just modified it, which is easier to the students. Okay, it's got a 3-step plan. Okay, here, guys, I use all letters because that's what you use in math, and then I'm going to water it down to some of the students' level by putting number signs. But in the meantime, you have to say what the letters are. Let all letters be real numbers. Augmented. This is reduced row echelon form, so this should look something like this when you're done. This will be the value for x, the value for y, and the value for z. Okay? Okay, now, here are the steps. Hey guys, I do it in 3 steps. A lot of instructors, and also the book, they use about, at times, between 8 to 9 to 10 matrices. I only use 3. And you'll be surprised how compact and organized my work is. Okay, 3. But each step has, at the most, 2 steps, which will be this one here, because remember, step 1 are in blue, step 2 are in green, step 3 are in red. So for step 1, this must be eliminated, and the I must be eliminated. These must be zeros. So, guys, remember when we did the system linear of equations, it was equation 1, equation 2, equation 3. When you use matrix, you don't say equations, we say rows. Because matrices are rows and columns. That's why we say rows. This is row 1, row 2, and row 3. So for step 1, right, I put A and B because it's 2 steps. This is A, this is B. I have to make those 2 zeros. So that has to change, and that has to change. After you execute it, this is how it should look like after step 1. Okay? Now step 2 is going to be in green. So for step 2, that must be a 0, right? Because this is step 2 in green, that must be a 0, and that must be a 0. So then, you see, these 2 must change. That's why I put the arrow here on top for the first row and the bottom for the third row. So after you execute step 2, your matrix should look like this. And then in red will be step 3. Step 3, this has to be a 0, and that has to be a 0. So that's going to change the first row and the second row. after you do that one, to only have 3 matrices, you simplify as you go along if possible. You see, simplify if possible as you do each step, and this way you guarantee to only have 3 matrices, 1, 2, 3, and that's the answer here. You see, guys, this is my answer. Okay, now let me redo this slide, but in a version that if you don't understand with letters, maybe if I just put number signs, maybe it'll make sense to you. To some of those students. And again, I don't like to leave none of my students behind. That's why I do whatever I can so none of my students get left behind. Because at times when a student doesn't understand a concept or something, they begin to withdraw from the class because they feel lost. So this way, nobody will feel lost in my class. Actually come for tutoring and they pay attention. Again, it's the same one as the other slide, but I just use number signs. Okay, I'm going to go a little bit fast here. You see, I use number signs instead of letters. So the student will get confused with the letters. So this is the answer as before. And this will be the answer for X, the answer for Y, and the answer for Z. Now, let's put the 3-step plan into action. Okay? That's the same problem that we had earlier. Okay, that's the augmented form, so it has to look like this when we're done. Right? That was the answer. So here we go. I'm gonna do this steps in the 3-step plan in 3 different slides. This one will be step 1, the next one will be step 2, and the third slide after this one will be step 3, and the final answer will be on that slide. So that's row 1, row 2, and row 3. So what's the plan here? Remember, guys, step 1, this has to be a 0, and that has to be a 0. So those two have to change. And in step 1, row 1 stays the same. And in step 2, row 2 stays the same. And in step 3, row 3 stays the same. Okay? That has to change. And the 3's got to change also. That's why I put them in blue. Okay, now, check this out. Because remember the plan that we had for the equations when we did it the other way, a solving system of equation with 3 variables. Remember we used equation 1? Same thing here. So this one I need to multiply by -2. But you're going to say -2 row 1 plus row 2. And here I'm going to say -3 times row 1 plus row 3 will guarantee to eliminate the 3 on the x's here on row 3. So then, how do we do the work? We do it here on the bottom. And this is how I tell my students to do it and show me the work here. Because these you can plug in the calculator, guys, and get the answer real quick. But I always tell my students that I want to see the work. You see, here it is. -2 row 1, right? This is what I'm doing here. -2 row 1 equals to -2 times row 1. This is row 1 here, right? That's my row 1. So it'll be -2, 6, -4, and 0. Plus row 2. This is my row 2 there. If we add them, you see, we eliminated that slot became a 0. So that's my new row 2. Or remember from before, new equation 2. That's why I try for you guys to make that connection there. And we repeat the process for using row 1 and row 3. So here, guys, this one I need to multiply by -3 times row 1, and there it is. And if I multiply -3 times row 1, that's what we get. -3, 9, -6, 0. Plus row 3. So this is my new row 3. You see, guys, I'm done with step 1. Now, on the next slide, I'm going to do step 2. So I'm going to continue here, guys, okay? You see, there's my step 2. This is what I got for step 2, right? Now, step 2, remember the objective. Now, step 2, these must be 0. So these must cancel right here. And I'm going to be using row 2. So here, guys, step 2, remember that row 2 stays the same. And step 1, row 1 same. And step 2, row 2 stays the same. So that's going to change, the top one. And also the bottom one I'm going to change from row 3. So here, guys, like we did earlier, this one I multiplied by 4 and this one by 3. So it's going to be 3 row 2 plus 4 row 1. And same thing over here. -10 row 2 plus 4 row 3. So here's my work here. So 3 row 2 will give us 0, 12, -9, 9. And for row 1 will give us 4, negative 12, 8, 0. So you see, guys, these will cancel right there. So that's my new row 1. And now repeat the process for the bottom one. Negative 10 row 2 will give negative 10 times row 2 will give me 0, negative 40, 30, and negative 30. Plus 4 row 3 will give me 0, 40, negative 28, and 28. So here, guys, is where we're gonna simplify, right? Because I want to make that a 1, right? So we divide everything by 2, and it's going to give us 0, 0, 1, negative 1, and that's my new row 3. You see, guys, I'm done with step 2. Now comes step 3. So step 3, the next slide is going to have everything up to here. There it is. Okay? So step 3, guys, these two must be zeros, right? So step 3, row 3 is the same. That has to be a 0, and that has to be a 0. So here, guys, I'm going to use row 3. Won't it be just row 3 plus row 1? And here, won't it be 3 row 3, 3 times row 3 plus row 2? And here's my work. Simplify, because everything can be divided by 4. So we get 1, 0, 0, 2. That's my row number 1. And then we're going to do the work for 3 row 3 plus row 2. You guys can follow it because I'm running out of time. And this will be, and simplify it, this will be equation number 2, or row number 2. So what's my answer? What's my solution? X equals to 2, y equals 0, and z equals to negative 1. Okay, now, guys, for the sake of finishing off, let me stop the PowerPoint and go to the next one. You guys can follow this one at your own time, okay? Because the next one is a word problem, which I'm going to help you set it up, okay? Let me in the show, and let me go to our last slide, the one that we're at. Okay, we're going to be, that was the one that we skipped, and you guys can follow it. Please try to follow it, guys. Send me an email, and I'll send you this PowerPoint, and maybe you can follow it. But let me go straight to this one here, okay? Let me start the slideshow from there, because I want to make sure that I get this one done. Because here is where a lot of students get confused, okay? So this is also a problem that I got from the book. You have to set up 3 equations. Okay, here it is. Let tickets to a band concert cost $5 for adults, $3 for teenagers, and $2 for preteens. There were 570 people at the concert. The total ticket receipts were $1,150. 3/4 as many teenagers as preteens attended. How many adults, teenagers, and preteens attended the concert? Okay, so again, what's my plan? Solution. Need to find 3 equations. The first 2 are very, very easy, or similar to the one from before. But the third equation is the one that gives students the most problems. And I came up with a technique to help you get the third equation, okay? So let's continue. That's why, guys, I wanted to do this one, because I want to make sure that you guys get exposed to this one, because this is the one that gives students the most problems. Okay, I'm going to set up the first 2 equations. Again, people with people, right? So because adults, teenagers, and preteens are people, and the money with the money was my setup. So let x equals to adults, let y equal to teenagers, and let z equals to preteens. And there are a total of 170 people, right? So again, people with people. So when it be x plus y, like x adults plus y teenagers plus z preteens must equal to 570. There's my first equation. Okay? Now money with money. Adult tickets were $5, right? So if adults represented by x, so that would be 5x. Teenager tickets was $3, right? $3 is here. So when it be 3y, and the preteens up here is $2. So preteens were $2, right? So preteens is represented by z. So that will be 2z. And what was the total receipts or total money? 1950, right? So there's my second equation. 5x plus 3y plus 2z equals to 1950. Now, so we got the first two equations, right? How about equation number 3? We need equation 3. So this right here, guys, the 3/4 is where you get the third equation. But here's where a lot of students are confused. So they're talking about teenagers and they're talking about preteens, right? So we have to have something with y and z. So this is what that means. 3/4 as many teenagers as preteens attended. So this is the equation for that one there. I know it seems kind of confusing, guys, but this is what I came up with that will make it easier for the students. Okay, because this is hard to get. Even as instructors, we're gonna struggle at times with those. Okay, but this is what I came up with to make it easier for the students. If it is difficult, write it how it sounds and then flip it. What does that mean? Is that in the book? No, I just came up with it because it makes sense. Once I do that, guys, it's gonna make much more sense. Hey guys, doesn't this sound as 3/4 y, right? So just put 3/4 y equals to x. And then flip it. Put the 3/4 where the z is. There it is. There's your setup. And it works every time. Believe me, guys, it works every time. So now, how do we find the third equation? Because we don't like to have fractions there. So we're going to multiply both sides by 4. Why 4? Because we don't want to have a fraction here. So 4 times y is 4y, and 4 times 3, 4z. The 4's will cancel, so we got 4y equals to 3z. But I need to let it equal to 0 because remember, guys, it has to be something like something x plus something y plus something z equals to a number, right? So we subtract 3z to both sides. And that's equation number 3. And that's the one that gives students the most problems here. That's why I skipped the last slide to get to this one, guys. So now we have all 3 equations. Now, I don't have time to actually do it, guys, but all these can be put into a matrix form. Come see me, guys, doing Sunday numbers, and I'll show you how to use the calculator, but you have to have a TI-83, TI-84, and I'll show you how to do matrices to make your work easier. But most instructors, like I'm including myself, when I give this on the exam, you have to show me the work. But you can always use your calculator, guys, to check your work. But I want to see the work. Okay? So try it at your own time, right? And these are supposed to be the answers. They're supposed to be 220 adults, 150 preteens, and 150 teenagers and 200 preteens. Okay? Now, this is not for you guys, okay? This is for the students that actually didn't attend. They have to do a survey and other stuff, and I think you guys too. So I think you guys do a survey, guys, a survey on how do you think I presented this PowerPoint. But anyway, guys, we're done with the PowerPoint, and I believe I finished just in time. Do you guys have any questions? Hey guys, questions on the material. I know that I went a little bit fast, but you know what, guys? I wanted to make sure that I got all the info. Okay, now if you want a copy of the PowerPoint, please send me an email, and I'll make sure that you get this copy of this PowerPoint there. Okay, let me stop sharing, and here we go. So, questions again.
No questions at this time, Mr. Azasi.
Okay. Well, thank you. And I know, guys, this section is a little bit challenging, especially with the Gauss method. So just follow the video, guys, or the PowerPoint, and hopefully that's going to help you with some of your assignments. Okay? Thank you.
Thank you so much to Mr. Isasi for presenting the material today. Thank you again to the audience for coming and being wonderful. We hope to see you again soon. Right now, we are sharing the Happy Math Hour virtual events for this month. We will not have an event next Friday. because it's an institutional holiday, but we will resume our Happy Math Hour events on Friday, April 9th. So you're more than welcome to give us another visit then. Also, we have tutors standing by in case you have any questions or you would like to ask us anything else.